Now, let us discuss about the torque or moment of force. The torque or moment of force, it is a quantity analogous to force in the translational motion. We saw angular momentum is a quantity analogous to linear momentum in translational motion. Same way, the torque is a quantity analogous to force in the translational motion. So how do we define torque? Torque, the rotating effect of a force about a point, that is measured as the product of force and the perpendicular distance between the point and line of action of the force. So force multiplied with the perpendicular distance between the point and the line of action of the force gives you the torque. The equation torque is represented by rho equal to force F into R perpendicular, the perpendicular distance. Now let's calculate torque acting on a particle. Suppose we have a particle at point P. Its position vector with respect to the point O is vector R. A force is acting in this direction. Force is F. This angle is theta. So this angle also will be theta. Now, this is the line of action of the force. Now let's draw a perpendicular from O to this line of action of the force. So ON is the perpendicular distance between the point and the line of action of the force. So torque is equal to F ON, the perpendicular distance. So from triangle OPM, if you take sine theta, opposite side is ON, hypotenuse is OP, which is nothing but the magnitude of the position vector R. So ON is equal to OP sine theta, which is equal to R sine theta. So torque tau is equal to F ON is R sine theta, F R sine theta. Now this R sine theta, the ON, the perpendicular distance between the point and the line of action of the force, is also called the moment arm or lever arm of the force. Moment arm or lever arm of the force. Now in vector notation, the torque tau is given by the cross product of R and F. Magnitude, as said earlier, it is RF sin theta, and the direction, since it is a cross product, the direction of the torque will be perpendicular to the plane containing R and F. And the exact direction is given by the right hand rule. I have to turn a screw from R to F in the direction in which the tip of the screw advances. So in this case, you have to turn the screw from R to F in this direction. So the screw will be advancing in this direction. So the torque will be perpendicular to the plane containing R and F and away from the plane. Unit is Newton meter. Force has unit Newton and R has unit meter. So Newton meter is the unit. The dimension is ml square t raised to -2. And interestingly, this unit is same as unit of work, Newton meter, and the dimension is same as work done. Now let's calculate the torque in terms of the components of the vector R and F. So we imagine that the particle is moving in a plane and force is also acting in that plane. So the position vector is given by xi plus yj. In the plane xy plane, xi plus yj, and force is fxi plus fyj. So take R cross F. So when you take the cross product, R is this is F. You have to multiply each term of R with every term of F. So as you multiply, here you will get I cross I, here J cross J, here J cross I, and J cross J. And cross product of I with I is 0. So this is 0. And this is also 0. I cross J is K, J cross I. Opposite of K, minus K. So this will be xfy minus yfx K. So what is K? K is the unit vector in the direction of the z-axis, which is perpendicular to this, perpendicular to the plane. So Rn, if R and F is the xy plane, torque is along the z-axis.